Okay, here we go. We got lesson 9.6 now. Yes, I'm wearing the same clothes from lesson 9.5. Just happens to be the same day still. Okay, so it might be a different day for you, but I'm still going at it here. So, lesson 9.6 here. You can see we still got that tangent word. Lesson 9.5 was all about tangents. New word here is secants. Secants, and then we're talking about some angles along with those two different types of lines. So we'll talk about secant here in a little bit, but that's a new word. So, a little bit of review first. Over lesson 9.5, we had some questions like this. Now, if you guys remember, a radius and a tangent need to make a right angle together. So if that's a right angle, that'll happen because it tells us that the line is tangent to the circle. So if that is tangent, then that means they want us to use the Pythagorean theorem on a picture like this. So remember, opposite the right angle, that's going to be my C. The other two are my A and my B. So x and 9 will go on the left side of the equal sign, and then 15 will be my C on the right side. So when we're solving it down, I got x squared, 9 squared is 81, 15 squared is 225. This time here, I'm not going to add them because they're on opposite sides of the equal sign, so I need to subtract the 81 over. So that'll give me x squared equals 225 minus 81 is going to give me 144. And the final step is square root of 144, which will give you 12. Okay, so x would equal 12 on this one. Okay, just using Pythagorean theorem because we have a right triangle because of that right angle there. If you have two sides given to you, to find the third, you use Pythagorean theorem. Okay, and the other main type of question from lesson 9.5 was pictures like this. If you guys remember, if they come from the same points, and both of these lines are tangent, remember tangent means it just touches it at one point, then those two are the same length. Okay, so if those two are the same length, you got to think, set them equal to each other in the equation. So I'm going to start off with 3x minus 3. 3x minus 3 is going to be the same size as x plus 7, so I set them equal to each other. Solving it down, maybe I subtract this 1x over. Keep my x's together. That'll make it say 2x minus 3 equals 7. Then I've got to move this 3 over, so I need to add it to get it to the other side. So then I'll come up over here, that'll give me 2x equals 7 plus 3 is 10. Divide by 2, we got our answer. X equals 5. Okay, so just a couple review from lesson 9.5. Let's move on to our lesson 9.6 stuff. Okay, first thing here, we got a new term. The term secant is our new word of the day. Okay, it's a line that goes through the circle. So, if you guys remember back in whatever lesson it was, 9.1, when we talked about chords, that's a chord. And this is a chord. Any chord is a line that starts on the end of the circle, starts on the circle, ends on the circle. Now what a secant is very similar to a chord. I got my, a chord just stops and stops. A secant is a chord that keeps going. So it's a line that hits the circle twice. It's always going to hit the circle twice. So it goes through the circle is what the definition says. It hits it, goes through it, hits it again, and keeps going. So a secant is a line. A chord is a line segment, where it stops and it stops. Okay, so that's what we're going to look at today. I have a lot of secants going through there. And we're still going to have some tangents also. Remember what tangents do. They just touch the circle at one point. Remember, that's a tangent. But the new one today that we're going to add on is secant. Okay, we're talking about when they cross, what happens when they cross, and things like that. Dealing with like the arcs on the outside and the angles on the crossing points. Okay, here we go. First type of crossing is when the two lines cross inside the circle. So we have two secants crossing, but this crossing point is not the center of the circle. That's the main difference. These two secants can cross anywhere inside my circle, but it doesn't have to be at the center. Okay, so we got a little theorem here down here. It says, if I have this picture right here, and say I'm trying to figure out angle 1. The way I get angle 1 is it's going to be, you want to add the arcs together. Now they're red here on my screen here. Add arc AB and CD together. So it'd be the arc that goes with it, arc AB, and the opposite arc. If I add those two together, and then it says multiply by 1/2, I'm going to say divide by 2. If I add these two arcs together, whatever they are, and then divide by 2, that's how big angle 1 is. And if you guys remember, vertical angles, if I figure out angle 1, I'm really figuring out that angle too. These two angles will always be the same size because they're vertical angles. Okay, and the way you figure those out is you add the two arcs that go along with them and divide by 2. Okay, so say they give me like 80 right here and maybe 100 right there. Add those two numbers together, divide by 2, I got my answer. Okay, so that's the idea here when they cross inside the circle. It works the same way for angle 2. Angle 2 is the exact same idea. I use the arc that goes with it, BC, and the opposite arc, AD. I add those together, divide by 2, that gives me angle 2. Okay, so here we go. Let's do a couple examples on this, practice it up a little bit. Okay, here we go. First one here says find x. So you can see, you kind of tell by looking at it, it's not the center of the circle. The center of the circle is going to be somewhere in this area here. So if it's not the center, I can't just say, oh, it's 88, because it goes with it. If it's not the center, you have to do the whole add them together and divide by 2. So I'm going to add 88, because it's the arc that goes with it. So x equals 88 plus the opposite arc, which is 76. I'm going to add those together. Whatever I get there, I'm going to divide it by 2. Okay, so 88 and 76, it's at 164. If I divide that by 2, that x angle is going to be 82 degrees. And then so the angle opposite. Remember, this is 82, that's 82 there also. Okay, so those will be 82 degrees. Okay, let's try another one. Okay, this one's a little bit different. If you look where x is, x does not go with the arcs that they gave me. This angle here, x, would go with this arc, and the opposite arc would be this one right here. Since they don't give me numbers there, there's really only one way to do it, but it's kind of hard to kind of get going. So the way you want to do this one, instead of finding angle x, how about I put like maybe a y right here, this angle right here. If I can figure out that angle, then I'm going to be really close to figuring out angle x. So I'm going to figure out angle y first. So if I'm going to find y, I'm going to do it the same way as did the last question. I'll add 62 and the opposite arc 96. So y equals 62 plus 96, then divide that answer by 2. So y equals, it's going to be 158. 158 divided by 2, y equals 79. That's not my answer, because it wants x. Now you guys at home, maybe you can figure out what to do here. If y is 79, y and x, you guys remember a linear pair? They share that side there, and together they make this straight line. Y and x there together. So if I have 79 there for y, these two together, a full straight line, is always 180 degrees. So if I have 79 there, x is going to be the rest of the 180. So 180 minus 79. That's going to tell me how big x is. Okay, so 180 minus 79, that's 101. Okay, so x equals 101 degrees. Okay, so getting started here. Some people might have started just by looking at the question. You might have thought maybe I could figure out this arc and figure out this arc. Going by what they gave me, there really is no way to figure this arc out or this one. So I just need to do it the way that I did right here. It's the easiest way, and as far as I know, it's the only way to kind of do this question. Figure out that angle and then do 180 minus. Okay, one more type of question they're going to do for you, a little bit different, is when they tell you how big the angle is, and we have to find one of the arcs. So the way we've been doing the last couple questions is the angle equals arc plus opposite arc, and then divide by 2. Okay, so that's going to be the same idea here, except I'm not going to put both my numbers here like I've been doing. This time I have the angle measure, so I'm going to put the angle number there, and then my two arcs will go over here, and we'll try to solve it out. So my angle number this time is 60. That's how big the angle is. So I'm going to put that here in the angle spot. Now arc plus arc is the arc that goes with it and the opposite arc. So that is x plus 25. Then my divide by 2 is still there. So this time I can't go straight to my calculator. I can't just do plus plus, divide by 2, and I'm done. I got to think how to solve this equation. So anytime you have a fraction, easiest way to solve from here, if you can, is get rid of the denominator, whatever's on the bottom. So if I'm dividing by 2 right now, the way you want to get rid of that 2 is you want to multiply it on both sides of the equation. Because what's happening here, if I'm dividing by 2 and multiplying by 2, they're going to cancel each other out on the right. So that's going to make my fraction be gone, really. It's just going to leave the numerator on that side. Get over here, 2 times 60, just 120. So over here on this side, I don't actually multiply anything by 2 because those 2's just canceled out, leaving x plus 25. And now hopefully it's pretty easy from here. X plus 25 means I need to get this 25 to the other side by subtracting. So 120 minus 25 will get you 95. And then to be perfect, you're going to put a little degree symbol on there. Okay, so that's when they give you an angle. If they tell you how big the angle is, you got to kind of work a little bit backwards to do that question. Okay, now here's a couple more where things that we just did. Remember the idea here, you want to add these two together, divide by 2. That'll tell you how big these angles are. Then, x and that angle make a straight line, so that's 180. So then you would do 180 minus whatever answer you get for those angles there. So if you want to try it out, see if you get the right answer here. Correct answer should be 98. So you can try it out, see if you get 98. Trying to do that question there. Okay, and this one is the exact same as the one I just did a little bit ago, where we had 60 degrees in the angle. It's the exact same setup. If they tell you how big the angle is, you're going to do that angle equals arc plus arc, and then always divide by 2. X plus 30 divided by 2. And then just follow those exact same steps I just did. Multiply the 2 over, and then subtract your 30 after that. Okay, we should get our answer of 104 on that one. Okay, so that's a little bit of when the two secants, right now those are two chords, but when two secants or chords cross inside a circle, but it's not the center, you do this right here. Add the arcs together, divide by 2, that gives you the measure of the angle. Okay, so that's when they cross inside the circle. Next one here is where we have one secant line and one tangent line. Okay, so looking at my picture, this line here would be a tangent. And the secant, if it hits on the same point the tangent touches, then we got some relationships going on here. So in a tangent and secant cross, a tangent and a secant cross, they have this relationship here. Angle 1 is going to be half the size of arc AB. Okay, so arc AB is this red one here. This arc is twice the size of the angle, or the way they put it is the angle one is half the size of this arc. So they tell me this arc's looks like maybe like 130. If that's 130, then I would do 130 divided by 2. 130 divided by 2 tells me how big angle 1 is. Same thing on this side. This arc here is twice the size of angle 2. So then I would just divide it by 2, or if they tell me the angle, then I would multiply by 2 to get that arc. So when we have this secant cutting through, it's kind of like cutting your circle into two different parts. This part goes on this side here, so that arc goes with angle 1, and this arc goes with angle 2 on that side. So here we go. Nothing too hard on this set, just trying to figure out the picture is the hardest part probably. So here we go. It says find the measure of angle QPS. QPS. Remember 3-lettered angles. The middle letter is your important letter. Follow that along. We are trying to figure out that angle right there. How big that angle is. So this one should be pretty straightforward. They tell us this big arc right here is 250 degrees. The relationship between that arc and the angle on this side is the angle is half the size of the arc. So if that arc is 250, all I'm going to do is just do half of 250. Easiest way for me to do half of a number is just divide it by 2. 250 divided by 2 would be 125. So measure of angle QPS would be 125 degrees. Okay, and there's ways we're going to do it on the next question where we're going to have maybe a number here and try to find something on the other side. So sometimes you have to work a little bit more, but still not too hard. So make sure you understand the question. Okay, this one now is wanting us to find an arc. That's why they got this little thing above it. We're trying to find the measure of arc BCD. So the measure of arc BCD. Trying to find that arc right there. Okay, picture it's a little bit different because the tangent doesn't go all the way through like it did on the last couple. But if it hits here tangent, and we got the secant hitting at the same point, that same relationship happens. If this angle is 108, the arc that goes with that angle, this arc right here, is twice the size. So if I know the angle is 108, I'm going to do 108 times 2 to start with, which is going to be 216. That's how big this arc is, not the arc I'm looking for. The arc that's on the same side of my line. So this arc's 216. Then, some of you guys probably already had it figured out. But remember a circle. Every circle has 360 degrees. So if I know this part's 216, the rest of it is going to be 360 minus 216. Do that in your head, or however you do it. Get 144 for that arc. So the measure of arc BCD is 144 degrees. Okay, so that's just using the whole times 2 divided by 2, depending on what they give you. Okay, a couple multiple choice here. Same idea as before. If I'm trying to get an angle FGI, that'd be that angle there. They gave me 225 on the same side of my line. So if this arc is 225, the angle is going to be half of that. Okay, so that's the relationship. This angle is half the size of that arc. So half of 225, 112.5. Okay, and one more before we move on to the last type of questions. UVW, exact same idea. If I'm trying to get this arc here, to me the easiest way, there's other ways to do it. To me the easiest way would be find this arc first, using my angle. If this is 99, the arc's going to be twice the size. So I multiply that by 2, that gives me 198. Then I want the rest of the circle. The rest of the circle, how many degrees are in a circle? 360. 360 minus 198. That's how they're getting 162 there. Alright, so that's just dealing with a secant and a tangent. When those two meet together on a point, that's the relationship. Either times 2 or divide by 2, depending on what they give you. Okay, last type of questions are when these two lines are crossing outside the circle. What we've seen so far is they crossed inside the circle. Then we had a tangent and a secant crossing on the circle. So we've seen this, and we've seen this so far. Now the difference is when they cross, they're crossing outside the circle. Okay, so the way we're going to do these, they all look a little bit different, but the way you solve is the exact same way for each of these different options. So when you cross outside the circle, ooh, it's sloppy. This is the idea right here. Your angle is going to equal big arc minus small arc divided by 2. Angle equals big arc minus small arc divided by 2. So I'll look at all three of these real quick here, kind of show you the idea. So the first one is when we have two secants. So two lines that are going through the circle, and they cross out here. What I mean by big minus little is we always look at the stuff that's between your two lines. So like in this one here, I don't care about this arc or this arc. I'm looking at the arcs that are between my two secants. So arc DE, that's my bigger arc. BC is my smaller arc. What you want to do is do bigger arc minus smaller arc. Then they put times 1/2. I like divided by 2 a little bit better. Okay, so I would do big arc minus small arc divided by 2. That minus that divided by 2. Same thing on this one. I got a secant and a tangent. Again, I'm looking at the stuff that's between my two lines here. Bigger arc here, DC. I'm going to do that minus my smaller arc, BC, and then divide by 2. Big minus small divided by 2. That's going to tell me how big this angle is, and this one over here tells me how big this angle is, how big those angles are. And then the last one, same thing. If I have two tangents, there's not going to be any parts cut off. It's going to be, the whole circle is going to be used. I just have a bigger portion and a smaller one. I do big minus small divided by 2. Now another way to remember big and small, if you can't really tell which one's bigger, the one that is farther from the angle, so if I'm looking at an angle right here, the one that's farther away, that's always your bigger arc. If it's hard to tell which one's the big and which one's the small, the one farther away has to be bigger, just by the way the lines are going. So the one farther away is my big, the one closer is my small, big minus small divided by 2. Okay, so here we go. We'll do a couple of these, just to kind of show you the different ideas, but here we go. Okay, first one that they gave me is a little bit tougher one. So I'm just going to write out what I just wrote on the last slide. Angle equals big arc minus small arc divided by 2. But what they gave me here, they didn't give me the big and the small arc. They gave me angle E is 62 degrees. They gave me this arc AD is 141. And we're trying to figure out arc BC. So we just got to fill in our stuff in the correct spots and try to solve it down. So here we go. Angle. The angle is 62 degrees. So we'll get 62 equals big arc. The one farther away is your big arc. So that'd be 141. Minus my small arc is the thing I don't know. This part right here. So I'll put a little x right there. That'll be my x. So 141 minus x, and then divide by 2. So we kind of did this earlier with when they crossed inside the circle. To make this a little bit easier, the first step is going to be, if it's dividing by 2 right now, if my denominator is 2, I'm going to multiply both sides by 2 to get it out of the denominator. So if you guys remember over here on the right, they're going to cross out, cancel each other out. 2 times 62 is 124 equals, over here I got 141 minus x because the 2's canceled out. Yeah, we got 2 little steps here to finish this off. This part here gets a little confusing for some people, but understanding the idea, this is a positive 141. I need to move it over. So if it's positive 141, I need to subtract it on both sides. So 124 minus 141, it's going to give me a negative number, which is okay, negative 17. The reason that's okay is because over here on the other side, I have a negative x. So equals negative x. Okay, that last final step, if that's a negative x, what I like to think of that as is a negative 1. So the final step, to get that negative 1 off of the x, I divide both sides by negative 1. So all it's going to do is just get rid of my negative, and it's going to do the same thing over here, get rid of my negatives there. So the x is going to equal 17, which is my answer, but I'm just going to write it a little bit nicer here. The measure of arc BC is 17 degrees. Okay, so that was a little bit tough. They gave me a pretty tough one to start it off. But you do big minus small divided by 2. If you want to test it out, you could do 141 minus 17 divided by 2, see if you get 62. Okay. How about another one? Measure of arc x, y, z. So they want to know how big is from x, y to z. So it's like from there to there. All the way around there. So what we have here in this picture is we have 2 tangents, WZ and WX. Those are 2 tangents. They're telling me the angle here is 40. This piece of the circle, this arc, is 140. And they want this part. Now I could do that whole thing that I just showed you on the last slide, which is a good idea. Using this thing right here, I'm just going to write it out. Big arc minus small arc divided by 2. You put all your stuff into there the exact same way we did the last one, except this would be my big arc, so I put like an X right there, and the 140 right there, and then I put 40 right there. That's great. Go through those steps, that's perfect. But if this is 2 tangents, two tangents are probably the easiest ones, because they really can't make a tough example. Because there isn't any part of the circle being cut off. Like from Z and X, we got this part of the circle and this part of the circle. There's nothing cut off that I'm not using. So if I'm using the full circle, just think logically here. Think how many degrees are in a circle? 360. Every circle is 360. If I know this piece, this arc is 140, then I don't care about that 40 at all, really. Just think logically about a circle. If this is 140, the rest of the circle is what I'm wanting. All I have to do is just do 360 minus 140. That's the rest of the circle. Now, it doesn't work every time. The last question that I did, I had to go through that work because there was little pieces cut off. But if it's a question like this, where it's 2 tangents, and they give you one of the arcs, the other arc's easy. It's going to be just 360 minus, and you got the answer. Okay, so measure of arc, x, y, z. It's 220 degrees. Okay, so a couple multiple choice here to kind of finish it off here. Same idea as before. See how this one's kind of like the one I did a second ago, the harder one. Because you can see there's pieces of the circle that I'm not using. So I can't just do 360 minus. I got to go through those steps. The angle equals big arc minus small arc, so I'll call that x, I don't know it, divided by 2. And it's the exact same steps. Just to save time, I'll kind of just leave it there. Remember, the next step is going to be to multiply both sides by 2. Then you would subtract your 135 after that. And in the final step, since that's a -1, you divide by -1 to finish it off. Okay, but final answer there should be 23. So if you want to check it out, do some work on your own, make sure you know what you're doing there. Hopefully you get 23 degrees for that little arc QS. And the very last one here, same idea as before. Just don't overthink some of these questions. Use your mind, use your little noggin here to try to finish some of these questions off. If this is 130, and I'm trying to get the rest of the circle, 360 minus. That 50 is just extra info. Doesn't matter at all. If I want the rest of that circle, 360 minus. You got the answer. Okay, so that's the end of the lesson. Don't know where my stuff's at. There it is. 9-6 worksheet to go along with this. It's going to be on the same attachment there along with this video on your Google Classroom. So, other than that, it's going to be the same stuff. We'll have an IXL that goes along with this stuff to give you guys some practice. And then I think I had a worksheet over 9.5 and 9.6 for you to do on the next Monday. Okay, so if you're confused on anything, let me know. But hopefully this video will help you get this stuff done. Thanks for watching.